Hi everyone, good morning.
Good morning, sir.
Morning. Okay, so today we'll just cover this use case and I'll wrap it little early today as I have some meetings to attend. Okay, so we'll quickly get into the use case. So yesterday we discussed about K-means algorithm. So any questions on that algorithm before we start we get into the use case?
No, sir.
All right. So if there's no questions, then let's get started. So basically, this is the data set. Okay, here I have around 800 odd customers. Okay, so these are the customer IDs, and I have some details about them. Okay, so the age of the customer, education, years employed, so on and so forth, right? And I have income, uh, the debt on the card, other debts, okay, whether they have defaulted in the past or not, their address, and their debt income ratio. So these are some of the information I have about these customers, which I feel would be important to segment these customers into multiple groups. So if you have to do it manually, just imagine, how difficult task it would be, to categorize these many customers manually. And you will see uh, the value of these algorithms like within few minutes, okay, within few seconds rather, okay, it will able to cluster all these 850 customers into various categories. Okay, so I'll quickly get into the code now. Okay, so here we will use another module in sklearn, which is named as cluster. And in this cluster, we have this algorithm known as k-means, right? Rest all the packages you know about it. Okay, and in from the data sets, firstly, I will take some example just to show you, how this clustering works, and then we will get into the use case. So here I'm randomly generating the data. So you can ignore this part of code. This is just to show you quick example, okay, which I can plot because the data which we are currently using for that particular use case that cannot be plotted because it has multiple input features. So I cannot able to view it. So here I've just taken two columns, a sample data set which I have generated, and this is how the scatter plot looks like, right? And if I ask you to categorize these data points into multiple clusters, you can easily, by looking at this visualization, you can easily say that, okay, there are four clusters, right? Four groups, because it is very clearly seen in this particular chart. So this could be one cluster, this could be another cluster, this is another cluster, and this is another cluster. So now let's see, how this algorithm can also accurately can identify these clusters. So now how we can set up this algorithm? Let's first initialize. So here, when you use this k-means, in this particular k-means, you have to initialize a particular algorithm, which basically randomly it will initialize the centroids based on the number of clusters which you specify. So here, this is basically the that compute engine which we have to initialize, say k-means plus plus. Okay. And then here I will specify the number of clusters I want, okay, in this particular data. So here I clearly see in this data, I have four um, unique clusters in this. So here the n underscore clusters is your parameter where you will pass this particular value as four, and you will specify that to this algorithm that to identify four unique clusters. And this particular part, n underscore init initialization, I'm setting it as 12. So what it will do is this n underscore init is the number of time the k-means algorithm will run with the different centroid seeds. The final result will be the best output of this n underscore init consecutive runs in terms of inertia. So what it will do is yesterday we have seen that how this particular algorithm works. Initially, it randomly specify the centroids and then it will try to converge so that it can come up with a better clusters or the good clusters. As it is starting randomly from somewhere, so it could be a case that sometimes it may miss out a good clusters, right? So what I'm doing is I'm running this particular algorithm 12 times, and 12 times it will start from various locations, because in the first stage, in the first step, it randomly assigns those centroids, right, in that whole n-dimensional space. Like that, it will run it 12 different times, and in whichever run it will give you the better cluster, that would be your final output. So these are the important parameters which you need to pass, or the arguments you need to pass to initialize this particular algorithm. After that, what you have to do is you need to just say dot fit and pass that data, okay, which has only input variables, and it will give you the labels. So here, when you say k underscore means dot labels underscore, it will give you the labels. Now, what it has done is it will give you the output saying that the first observation is part of cluster 0. So 0, 1, 2, and 3. So these are the four categories which it has assigned to all the observations. So the first observation it has assigned to cluster 0. The second observation it has assigned to cluster number 3, and the third also it has assigned as cluster as in cluster number 3, so and so forth. It will assign all the observations to each of those clusters. Now, if you want to find out the centroid location, just you say the model name, the k underscore means. This is the name which I have assigned to this particular model. You can assign any name to this and say dot cluster underscore centers underscore. Now, these are the centroid locations of each of these clusters. Now, let's go and plot this particular scatter plot and also see that where those centroid locations are located in that particular chart. So if you see very nicely, it has identified these four clusters, and these are the central point of these clusters, which are called as centroids. So as we have manually seen that, okay, there should be four clusters, and very nicely, this particular algorithm has identified these four clusters, and these bold dots are known as the central location of these centroids of these clusters, which are called centroids. Okay, so now you have seen that how this algorithm works and how it can able to find out the unique clusters in the data. Now let's go ahead and solve this particular use case. So here we have the customer data and we want to segment these customers into multiple clusters. Now I do not have any idea because I cannot visualize this data because there are so many variables. When you have so many variables, you cannot plot and see either maximum you can plot 3D plot with by using three variables, but beyond that, it is not possible to view the data, okay, visually. So here I have to go with some kind of iterations at different k values, and then I have to see which k value is giving me a better clusters. Okay, so this is my data. Now here, uh, you have to see which of the variables could be important for you to cluster these customers, and whichever variables you feel are not significant, you can go and drop those. So here I see that customer ID, because these are all unique values. Okay, so even if it is there, it will not make any sense. You can go ahead and drop it. Age, of course, with respect to age, we can we can segment the customers. Based on the education, we can segment the customers. So all the variables looks okay. Again, the address. So every customer will have a unique address. So until unless you have a, a region or cities or country kind of information, it makes sense. Now these are the zip codes. Okay, so I don't think this is also uh, would be relevant. So I will drop this particular column also. So here I'm dropping address, being that is the text data, and I'm just leaving this customer ID as is. Otherwise, you can go and drop the customer ID also because it will not give any important information to this algorithm to segment the customers. Now, so after considering all the important variables, now the second important step in this K-means, which is very important and it is mandatory step, is to scale the data. Now here we are seeing the numerical, all our numerical data, right? So here again, these are at different scales, right? Education is at a different scale, age is at a different scale, um, debt income ratio is at different scale, right? So now what I will do is I will do the scaling and I will bring all these columns, all these variables to the same scale. Why is it important? If you remember in KNN, also we did scaling, and in KNN also scaling is a mandatory step. Uh, can somebody tell me why scaling is important, was important in KNN, and why is it important here in K-means? And this could be one of your interview questions, guys. So people may ask like, what kind of pre-processing you generally perform when you are using K-means or KNN? So here we are using scaling, and but why it is important to do scaling?
In both the cases, we use Euclidean distance to find the
Distance
Yes.
correct.
measurement.
Yes. So here, in both the cases, the common thing is like we find out the similarity between the observations, and for finding out the similarity, we calculate the distance. And we have discussed in KNN that if any variable, if it is at a higher scale, then it will dominate. Okay, and the distance measure will get biased towards that particular variable, which is at a higher scale. A variable which is at a very low scale with some decimal values like 0.001 or something, those kind of values, if it existing in any of the variable, those will be kind of ignored. Okay, when it calculate the distance. So to give importance, equal importance to all the variables, we bring all the variables to the same scale. So that's the reason the scaling is a mandatory step for KNN as well as for KMean. So here I'm performing this standard scaling. So standard scaling is nothing but I'm calculating the Z score, right? So these are all the Z score. Now the data looks okay. Now comes the modeling part. So here I'm going with cluster number equal to 3. As I mentioned, see, deciding the K value can be done in two ways. One is like based on the domain knowledge, based on business inputs. You can decide if somebody comes and tell you that okay, I want only three segments. I don't want more than that. Some or the other way, just segment these customers into three categories. So you just mention three and go ahead with this. Okay. So you need not to bother about whether these are good clusters or not. Okay. Based on some logic, it will categorize or it will come up with these three clusters. Okay. If the business says that, okay, I don't want, I want a very good clusters, okay, very unique clusters, homogeneous clusters, then you have to do multiple iteration and see that which K value is giving you a better results. And how can we find that? Yesterday we have seen it's a elbow method which we will use where we will run this particular algorithm at different K value, and at every K value, we will find out that overall distance within the cluster. Okay. Uh, And based on that, we can find out that elbow point, and that elbow point would be my optimal K value. So let's first go ahead with 3. Okay. So here I'm specifying the way we have specified initially in that particular example, the same way. And these are all my labels. So all my data has been labeled by 0, 1, and 2. So these are the 3 categories or 3 clusters. Now I have these cluster number assigned to it. Now what you can do is, see, now here I'm just running once, okay, but you can run this particular thing in by putting that into a for loop and run it multiple times, okay, and see which one is giving you a better results. So what I will do is I will add that particular part of code, okay, where I will show you that elbow graph also, and then I will share this particular code. Okay, now how you will validate? How you will validate this particular clusters is the biggest question. So one way is like you just give this data by labeling, to your business and ask them, to evaluate. Okay, so they must be doing something manually. So that is an external approach which they will follow to validate whether these clusters are making sense or not, whether they are aligned to what how they are doing it manually. Okay, if it is matching to truth. Another way is like that is known as internal search, or a technical way of looking at this is what I will do is I will group all these clusters, okay, and then I will find out the mean average value of each of these variables. Okay, so just ignore customer ID. So age, if you see the average age in this particular cluster is 45. The average age in this particular cluster is 32. Now the average age is in this particular cluster is 41. Similarly, sorry. Similarly, you can look at education, years employed, income, card debt. One particular variable may not give you the complete picture, but if you look at all the variables together, then you will get a perfect picture. For example, in this particular cluster number 0, so here the people are like, um, uh, they are uh, they are of higher age, okay, 45 something. Education, they are highly educated, okay, looks like educated, and years employed, they are like working employees working for quite some time, okay, and the income is also very high, average income is also very high. The card debt and other debts are also very high, and their debt income ratio is kind of low. So that means, and even the default, the number of the average time they got defaulted is also kind of a low. Okay. So now, with this particular, not for the business, now this particular cluster looks out to be a more potential customers because they have a high income, they are more, they are matured people, they are working for quite some time, and even their debt income ratio is kind of low. So these are the people whom they should target first because there is a high chance or there is a high potential that, okay, these customers will buy some products or services. Now, when compared to this particular cluster, if you look at this cluster, almost the age wise, they are same. Okay, but the education wise, it looks like, they are less educated. Even the years employed is relatively less than the first cluster. The major difference comes here, right? These are the similar people, but their debt income ratio is quite high. Okay, so in this case, and they have also not taken much loans also. Okay, but their debt income ratio is high because their income level is quite low when compared to the previous cluster. Now, this is the major difference between the first cluster and the second cluster. Majorly on the age side, on the years of employed, probably they are relatively same. But when you look at the income level and the debt income ratio, they are quite different. Okay, so this again looks like a unique cluster. And there's something, okay, it's a higher risk to target these customers because they are already very high on debt income ratio. Okay, and now comes this particular cluster, young people, okay, less educated, less years of employed. So this kind of a cluster can be ignored. They can take some risk here, but this is something, okay, can be ignored because if their debt income ratio is very high, but their income and the income is very low. So definitely they cannot afford to take any kind of debts or any kind of a loan, and they won't be able to repay those particular loans. So it's better to avoid and not to target these customers. So this is how you can validate whether these clusters are making sense. Okay, and this is how you can name these clusters. Okay, based on your domain understanding, you can name these clusters, label them, and once these customers got labeled, okay, now what? Now this is your data, right? Now here you have this label. Now all these customers are segmented into these clusters now. Now you can consider this data as a for a supervised learning. Okay, now you can run any kind of a classification algorithm on top of this data and you can build a predictive model. Now, tomorrow, if any new customer is coming into your database, okay, then it can rather than again taking the entire data and running this clustering technique, you can use that predictive model and you can predict that only particular instance or that only customer, and then you can classify that particular customer into either of these clusters. Okay, so one part is missing here, that elbow method, so which I will include that in, and that's very simple. Okay, it's just like you have to iterate this particular part of code on multiple k values, and then you have to measure that particular distance, overall distance. For that also you have one single function. Okay, with that function you can calculate the distance and it will give you the proper you can plot that elbow graph, and then from there you can identify the optimal k value. Okay, so very simple, but very effective. Guys, you can try on some publicly available data sets. You can just try searching on Google like um, some data sets for k-means clustering. You will get a lot of data sets, and then you can practice this particular algorithm, on those data. Okay, so any questions on this code? Now, finally, I'm just viewing this data based on the income and age. As I mentioned, you cannot plot the data on beyond three variables. So here I'm just taking two variables, income and age, and then just I've plotted this particular all the customers and then colored with the cluster number. Okay. So here you see that nicely it has segregated these data points. On the top, it is one cluster. In the middle, there is another cluster. Okay, in the bottom, there is another cluster, right? So there is no overlap. You don't see any green color between the yellow points or this, what is this purple color? Okay, so so this looks good. Now, as I said, there is no evaluation metric. You cannot say that it is 80% accurate or 90% accurate because there is no ground truth attached to it. If there is a ground truth, you can go and compare that. If there is a ground truth, then it becomes a supervised learning problem, right? So basically, why we go with the unsupervised learning? Because we do not have labels. We do not have that ground truth. We do not have that actual values. So that's the reason we go with this unsupervised learning. And there is no definite or discriminate uh, process of evaluating this particular algorithm, okay, or this particular model. So it's you have to put some uh, knowledge and some understanding about this particular domain to evaluate the model output. So as we have discussed, this all these three clusters seems to be unique, and it logically it making sense. Now, this is something you can validate, get it validated by the business and explain them why these clusters are looking unique to you, right? And if it makes sense to them as well, then you can go ahead and then you can label the entire data. And generally in the CRM databases, like customer relationship management databases, the segmentation algorithm runs behind the scenes, right? And it is frequently get updated. So how it works is, in the real scenario is, let's suppose I have 1,000 customers in my database, and those are not got segmented. So I'll run this algorithm, I'll segment those customers, and then immediately I will also train the classification model. Now, for a time being, I will use that predictive model, to classify all the new customers. And see, the whole environment in any business is more dynamic. The customer patterns would change, the behavior would change, a lot of other parameters or factors may change over a period of time. Then you have to again, so you cannot just fix those number of clusters which you have got initially, right? So maybe later, after a certain time period, there could be other clusters may also come up in your data. So after a while, after 6 months or 1 year, again run the clustering technique. So earlier, if you have got 3 unique clusters, this time you may get one more unique cluster added to that. So fourth cluster, you may get it. Then again run this clustering technique, again build the predictive model, again use that predictive model to classify the new customers. And then like that, you have to continuously enhance. Okay. Sometimes pattern may also change. So initially, let's suppose in this case, we got this pattern. So tomorrow there could be certain customers may get added to your database where the education is less, but the income could be more. Okay. So then it will bring one more cluster. Right? Are you following? So it's not like one-time job and you are done with it. So you have to continuously uh, update it continuously. You have to check whether these clusters are making sense in your data set or not, right? Even for any predictive model also, in that case, even the predictive model, it is not something like you train the model once and deploy it and your job is done. So continuous monitoring, maintaining and enhancing the model is very much important, for AI ML solutions. And this whole process is called as ML ops, machine learning operations. ML ops nowadays, it has become a very important for big enterprises, because what they are doing is they are building all the AI ML solutions, they are deploying it, but there is no governance around it. There is nobody's monitoring on it. It can happen that after a period of time, your model may deteriorate. The time when you have trained the model, um, it might be giving you 85% or 90% accuracy, but over the period of time, the data patterns may change. There could be more number of factors which could impact your business. So that model may become old, okay, and may not give you a better results. So you have to continuously monitor that whether your model is consistently giving you a better results or it is getting deteriorated. So there are certain techniques which will detect the model drift. If there is a big change in the overall accuracy of the model, then that's the time where it requires a retraining. Again, you have to go through the uh, entire cycle. Okay, machine learning model life cycle. You have to go and again look into all the variables, again consult with the business. Is there any new factors which I should include? Or you have to do that data enrichment. Again, you have to go through that whole pre-processing and model training activities and see that with a new data set, whether your model is now giving better results than before or not. Okay, so this continuous monitoring, continuous maintenance, continuous retraining is called as ML ops. Even the data. So now, for example, in my business, the average customer age is around 25 years, right? But over the period of time, it may not be always be the same, right? So maybe over the period of time, my average age has increased to 35 years. or 38 years. Now, earlier, when I trained the model, these kind of patterns were not existing in the data. But later, the environment changed, the customer behavior changed, the more awareness happened, your brand value has increased. So your business has made a big shift, okay, big change. Because of that, your data would also change. Now, again, it would be also important for you to check, is there any drift in the data? So what we do is we put some statistical measures. Okay. So for example, the standard deviation. So we calculate the standard deviation, the mean, the mode, the median, all those 5 point summary of the data, which we generally do in the beginning of uh, any solution, right? So we take those statistics and uh, we use that for continuously we monitor, we check in the new data, is the same variance is there or is the same standard deviation is there would be definitely a little bit of variation, but it should not be drastic. Earlier the mean was, let's suppose, 20. Now if it is like 50 or 60, then there is a huge change. So in my data now there is more higher values rather than it was there in before. So now the model which I've trained on the earlier data will not be uh, an appropriate model to run on this particular new data set. So so this is very important. You have to keep it in mind when you are building any solution. It's not something, it's a one-time job, right? So if you are deploying it, then there has to be a continuous monitoring and maintenance and retraining. So it's like support. So in my team, there are 5 or 6 people who are just on support, right? So their job is, to maintain uh, all the models. So they continuously track, they see that nothing is breaking up. So there are multiple applications in which that particular model is getting consumed. So their job is, to continuously take care of all those applications and continuously monitor. So we basically we create a dashboard, okay, where we track all those metrics for all the models. Model number one, what is the accuracy now? Okay, what was and how overall the accuracy looks like whether it is kind of constantly decreasing. Is there any drastic fluctuations in the accuracy? Sometimes it is giving 90, sometimes it is giving 60 or 50. So that is also not good. So consistently it has to give better results. So that's something through a dashboard these guys will monitor. And if they see that it is kind of not a good model, it is fluctuating too much, or if it is like gradually decreasing, the accuracy of that model is gradually decreasing. Now that's where they will go back and they will again retrain the model and again deploy it. And the deployment approaches are also different. Okay, this is something I just wanted to share. So here, how it works is it just works like the way things works in digital marketing. Sorry, in digital analytics. So, for example, now you have built one e-commerce website. Okay. Now, what you will do is it's not something you just build that website and leave it, right? You have to continuously analyze. So there is Google Analytics. There are multiple other platforms which will measure the whole journey, customer journey on the website. Once the person is logging in, okay, what exactly he's doing, okay, on that particular website, everything will be taken into consideration. How much time is he spending on a particular page, where exactly he is clicking, what exactly is looking for, what kind of searches he has made, how much overall time he has spent on that particular website. Finally, whether he has bought the product or whether he has made the transaction or not, everything continuously they will analyze. So now, what they will do is, so there is one tool, okay, which is a very cool tool. Okay, what it does is, let's suppose this is my entire screen, this is my website. Okay, now what it will do is, on this website, it will generate a heat map. Heat map means there would be a color gradient on inside on this particular page, which shows that where exactly people are clicking more, in which section. Okay, so through this heat map, let's suppose here it is a dark red color. So that means people are generally liking this particular section. Okay, so they are clicking more on this. Let's suppose it is a light pale yellow color. Okay, so that means here people are not even viewing, not even clicking. So whatever you are showcasing in this section of the page, people are not even, clicking on those particular products. So possibly they might not getting the attention here, or probably whatever you are showcasing in this part of section is not of their interest. It could be multiple reasons. Now here comes the time to revamp this particular web page. So now the web designers and all those things, they will think through it and they will try to change it. Now they will not abruptly change that particular website with this new website, because here in this original website, let's suppose people are at least viewing and clicking. What if you make any changes, and if the customers where they were clicking on this particular section, even if they not click on that particular section also, it's a risk, right? If you see any major changes on your website, on any website which you more often you go and use it, so possibly you may like it or you may not like it. If that change is good, then probably you like it. Otherwise, you will feel that I was very much habituated by that particular layout. Now they have changed it. So possibly you don't like it. So what they will do is they will have a two copies. One copy, the old one, the second copy, the new one, the new page. What they will do is they deploy both simultaneously. One is already deployed. The new layout, they will deploy parallelly. And what they will do is they will divide the traffic. So if the 100% traffic which was coming on that previous earlier website, now 50% of the traffic they will deviate to the new one, or they can randomly also they can do it. So the customer, whoever is logging in, can randomly can be routed to either of these uh, different pages. Now what they will do is they will leave it for few days and then they will monitor. They'll see that how the conversions are happening. Is it improved? Now, are people looking at in looking at the entire page or not? Is a similar pattern, or people are dropping? Are they spending more time? All there would be a different matrix which they will analyze and monitor. If they find that this new page is giving them the better conversion and better impressions, and people are spending good time there, then what they will do is now they will retire the first page and they will pass the entire 100% traffic to this new. Now just replace this websites with this model. The models also work in the same way. What this MLOps engineer will do is, let's suppose there is a first model which is running, okay, and the model is giving the predictions. Now, if if we see that there is a gradual decrease in the accuracy, and if it is like fluctuating too much, now it's the time to retrain the new model. Now, you will train the new model, but you're not sure in the production how that model would run. If it is like even worse than the previous model, then again it's a risk, right? So business will not be happy with that. So again, for that, they will divide the traffic. 50% they will retain on the same old model, and the 50% they will pass it to the new model. And now again, this new model will be tested on various metrics. Again, it will be analyzed, seeing that whether the accuracy is consistently maintained or whether it is again fluctuating more than the previous model or not. If it is like consistent, if it is not fluctuating too much compared to the previous model, then the entire 100% traffic will be passed to the new model and the first model will get retired. So that's a deployment strategy. Okay, so there are multiple. This is known as canary deployment, where we will slowly move the traffic or move the users to the new model. And again, another would be a blue-green deployment strategy, where you just retire the first model completely and then just onboard this new model and then pass the 100% traffic to this new model. Okay, so the purpose of sharing all these things is uh, to let you know that once you train the model, it's not something your job is done, right? So a lot of things goes after productionizing the model also. Okay, so continuous, and we call it as a governance. Yeah, so AI governance. So, and it's just something, I told you very little things, but once the model is deployed, a lot of other things also people would like to monitor. One is like your model should not be biased. Uh, Biased is very important. If let's suppose I trained a model to predict the default or to predict whether for the loan approval, let's suppose. If my model is biased towards a particular race or occupation or a gender, and then the banks can be sued based on that. And I don't have the control. In my past, in my historical data, let's suppose most of the loans has been rejected for females. So the model will learn that pattern. And tomorrow, if any female applicant comes and apply for a loan, my model may just directly may reject those particular loans. So now it's important for the banks to see that whether your model is biased. Okay, so if the loans are getting rejected based on the gender, based on the race, based on the caste and religion and whatever, okay, then those particular models cannot be used in the production. So generally, in the beginning only, we will make sure that those particular variables to be removed, and then through relative feature importance, we will check which of the features are significant. If the gender, race, those comes up on the top, like if they are the most important, then your model is getting biased towards those particular features. And generally, in the banks, these are not accepted. Okay, and even there are certain packages which I'll cover in the end. Even for every prediction, it will tell to which all features it has given importance for individual predictions, line items. So with that also, there will be a constant check which will be done whether those predictions are coming, genuinely, or is there any kind of a biasness in those particular predictions. So all this explainability, monitoring, maintenance, the retraining, support, this is very, very important because see here machines are making decisions. You cannot just uh, let it go just like this, right? You cannot give the complete control to the machines and let them decide whatever they want to decide. Right? So, because all the decisions are being made on top of that, if they are AI applications, so all the uh, tasks will be get automated and can be done through these machines, right? So, and if there is any wrong decision, you just imagine, how much damage it may do on the business, right? So, for example, in the customer segmentation, if the wrong clustering has happened, then it may impact the brand value, or it may just unnecessary. You will go and target those customers which are not potential. So a lot of efforts and the cost will be incurred. So continuous monitoring of these models is very, very essential. After productionizing these solutions. All right. So, any questions, guys? Okay. So this is about the key means. I'll take another 5 minutes just to let you understand how in the real world, okay, scenarios would be, right? So we are seeing a very ideal situation. So whatever use case, it's kind of looking very simple, like the data is there, neat and clean, right? And we are just running the algorithm and it is giving us the very good clusters, everything. So these are all uh, rosy kind of a scenario. But in the real case, what will happen is everything would be kind of scattered, okay? Nothing would be very clear. So, getting the clear picture would be the major challenge. So what will happen? I'll give you a one specific example how this overall this project comes, and how we deliver and what kind of challenges we face in the real scenario. What will happen is, let's suppose there is a sales guy. Okay, I'm talking about from the services point of view, and then I will also tell in the product based company how it works. In the services company, for example, TCS, Infosys, Wipro. So these are like IT services companies, right? Which provide services to multiple customers, multiple companies. So now there would be a lot of salespeople who will be assigned in each of the regions, right? Territory they will have. They'll start go and hunt for the new customers, or they would be existing customers also. They will keep going. They will keep meeting those customers. They will try to sell some new services to them. Let's suppose one fine day, one sales guy went to a particular uh, particular company, and he said that now we have a strong competency in place, okay, and we are serving our customers on data science and AI. Now, would you like to, or do you have any requirements around it, or do you need any support on the AI ML side? Now, this customer will say that, okay, sounds good. Okay, now we are also in that AI journey, and we are also doing a lot of things, and but would like to hear, what you have done. So probably if we see if there is uh, any kind of a synergy, if there is, then we would like to work with you. So that was a very initial high level discussion. What will happen with the sales guy? Now, sales guy will come back, and he may take more requirements also if he's more educated on AI, ML side, on data science side. He may ask more specific questions. What is your maturity? What tools are you using? What kind of use cases are you developing? What is your landscape? What kind of databases, technology, and everything the sales guy can, and he can come up with a very specific ask, saying that customer is looking out for supply chain analytics. Okay, and they have built these models, but here they are facing some challenges and they need our support. Now, all that information will be passed to this service line. Now, this data science is a one service line, right? So it's a one practice. So these leads will come to, so like that, multiple leads will come from all over different salespeople from multiple regions, right? Some leads would be at a very high level. Somewhere, someone will come up with a very specific requirement. Now, as a service line, we have to qualify those leads, which are more important. Who is that person with whom the sales guy is speaking? Whether he is an influential guy, whether he is a decision maker. If we influence that particular guy, can we directly get the business? Right? So all that evaluation will be done. Now we will go back and we say that okay, go ahead with this particular customer and go and schedule the meeting, and let's understand more. Now comes the pre-sales part. Now this is pre-sales. What is pre-sales? Uh, it is interaction before the sales, right? And here we go even further, we go deep dive in depth, and then we will try to understand, we'll try to convince. Now here there would be a technical person, okay, and I'm into pre-sales. So the person who can interact with the customer, who can sell the technology, who can understand the requirements, and on the fly can come up with some solutioning, and also can talk on the existing use cases or case studies, if the relevant case studies are there with the customer. Now, this would be a broad discussion. So here we will ask a lot of questions to customers saying that, okay, how they are doing, what pain points they have, and even the customer brings some technical folks also into the call, and all that convincing, requirement gathering, everything will happen in that particular call. It could be one call, it could be multiple calls also. Basically, lead to closure cycle happens, it takes generally more time, and it doesn't get closed in one single call. So we will have multiple meetings like that. So what we do is, I take my team along with me in these calls, and then we will plan a demos. We will show them the demos. We will talk about the case studies. We will talk about other customer stories, saying what kind of problems we have solved in supply chain or in manufacturing, if that's the interest of the customer, and how we have solved it, and what kind of benefits now customer is getting out of that. And that discussion will go on. Now, let's suppose after a couple of meetings, now the customer says that, yes, I see that you have the capability and you have the experience. So he can come back and he can ask me or ask us, uh, you know, to get engaged. And this engagement can happen in two different ways. In services company, what will happen is either they will say that, okay, I need two people who have worked on that supply chain and who have the experience of solving those kind of problems. There is because I have team, I have 4 to 5 data scientists with me, but probably they are not able to solve this particular problem. I need two of your folks, okay, who can support these team. So this is more of a staffing. We call it as a T&M, okay, time and material. So here, whatever number of hours these guys will go and spend in developing that particular solution, we will charge the customers only for that particular time. Okay, so this is more of a T&M. So if you are joining a services company, don't think that okay, you will be relaxed and you will be given a job, given some task. No, you will be get exposed to the customer, and sometimes customer again may take your interview. If they like it, then only they will onboard you. Otherwise, they will reject it. Okay, so that's how we give bodies to our customers, saying that we have 3 profiles. Do you want to talk to them? And if they like those profiles, then they go for it. And they generally ask at any grade. Okay, even they ask for freshers at 2 to 3 years of experience, even 8 years experience, and even people ask for 15 plus years of experience guys also as an architect who can run or who can lead their projects. So that's on the T&M. Let's suppose if the customer is coming and saying that, okay, can you build this whole solution? I just want to outsource this particular project to you. Okay. And then this is more of a fixed bid. Then we will scope that entire project and we'll come up with a proper amount. We say that, okay, now this particular project to build or the solution to build, it may take $10,000. Okay. And it may go on for it may take time around 6 weeks to 7 weeks. So all that estimation, scoping, assumptions, everything we will put it in one proposal and we'll share that with the customer. Then the customer will, again, we have to go and explain that whole proposal, our understanding, why we have included this, what architecture we are proposing, how much time we have estimated. So all justification and the rationale behind all those things we have to explain it to the customer. So generally, it does not get closed in one single call. So there would be negotiation, there would be a lot of questions, inputs, and everything. Okay, again, it will take some time. And then once they approve it, now after that, we will submit the SOW, known as Statement of Work. In Statement of Work, we clearly specify who will be responsible for what. Customer will be responsible for what. Uh, the vendor will be responsible for what. That means the service provider. Okay, so clearly we will mention that, clearly we will define again the scope there in a more detailed format. Okay, and the SOW will be signed, and after that there will be multiple agreements will also sign. We called as MSA, which is Mutual Service Agreement, or NDA, Non-Disclosure Agreement, and there is and in that there would be certain clause like GDPR's rules and regulations would be one of the clauses in that, which states that if any of the data of the customer, if we expose it somewhere outside, then they have the rights to penalize us. Okay, so that's the reason the data is very, very critical, and these service provider will uh, put all the governance in place so that the data is not moving out. If in case, by chance, if the data is leaked by you in some other way, then your job is on risk, because the companies may have to pay very high amount if anything such happen, irrespective of what is that project value. They have to pay a high amount. Okay, and it also happened 1 or 2 times in my company, after which, based on the uh, with the customer relationship, somewhere we have sorted and we have given them the discount and everything, and we managed it. But you have to be very, very careful when you are working on any customer project. Make sure your data is not going out of your system, okay, your company's laptop or desktop. Okay. So yeah, so once SOW is signed, there every timelines, everything will be mentioned, and then looking at when the resources are available, the team is available, we will decide on the kickoff date. And in the kickoff, generally high level, so all the project and project managers will be assigned, technical people will be assigned, the entire team will be introduced, the customer will introduce spots from his side. So all that discussions will happen and the whole plan will be discussed, how we are going to execute. And now this whole execution happens in an agile way. So agile, right? It's more of flexible methodology where customer can add any changes, not out of scope changes, but if he doesn't like anything during the process, uh, we have to accommodate those changes. Okay, so it's a very flexible methodology and constant review, constant updation, constant refinement happens in this agile methodology. Okay, so and then we will decide on the milestone that, okay, after, though it is a 10 weeks project, but in 2 weeks time, which would be the sprint size, and after every 2 weeks, we will deliver these things. And in that, after, let's suppose after 4 weeks, there would be a milestone where we will deliver uh, 50% or 60% of the overall solution, right? So like that, we will go and deliver. And then wherever they want us, to deploy, we will go and deploy that particular project. After that, again, there would be a 1 week of or 2 weeks of, depending on the solution, there would be hypercare where we have to provide the support. It's not like today I productionize it and tomorrow I will disappear, saying that, okay, project is done, my job is done. So it doesn't happen. So then always we make sure that there is a 1 week of support and hypercare. So whatever model is running on the production, so we will be at a standby, monitoring that if everything is working fine or not. If after 1 week, there would be a little bit of hiccups, okay, or uh, problems may come up, which we will resolve. And after a week, when everything is stable, then we will wrap up and then we will give them all the documents, all the manuals, all the training, everything, okay, the way they expect us to hand over that particular solution. We will do that. And that's how, the project wraps up. Okay. And now, if any customer wants anybody, for the support, then we will put 1 or 2 people, continuously for the support. So that's what I was calling as ML ops, right? So where they have to kind of automate the process, build the dashboards for monitoring, see that whether all the models are running um, properly or not, or is there any need of retraining. So all that thing, they will do. So this is how typically it works in a IT services company. In the product company, everything will remain the same, except that the customer would not be external customer, it would be internal customer. So if I'm a product based, I may get uh, some kind of requirement from different teams. Okay, marketing team can come to us and ask me. When I was with Deloitte, it is mostly like that. Okay, we were supporting the marketing team there. So my team was marketing analytics. So my customers was all the marketeers, who were directly uh, selling the services. Either this could be they could be sales or they could be indirect sales. So we were supporting them in developing some predictive models which can help them, to plan their marketing activities better or even to target the customers better, right? So everything was almost the same except that it was more of an internal customer, and we were knowing about the domain because we were into that particular company for quite some time, so we understand people, we know what they are expecting. But when it comes to IT services, every company is unique, every customer is unique, every customer will have a unique pain points. The domain would be different. Today, if I'm supporting any retail customer, tomorrow there could be someone, from manufacturing, someone from banking, and that too from any region. So if I'm working with a Middle East customer today, so tomorrow some US customer may come up. So like that, there is every day is a new challenge, guys, in this services company, because every time you will have to solve some altogether different problem. Okay, and it is not that easy, to even start. So as I said, nothing is clear in the beginning. You have to gain that experience where you will interact with the customer, understand the pain points, convert those pain points into analytical problem, and then give it to your team, to develop a solution around it. Okay, so there is a huge scope, guys. If you are starting your career, then definitely there would be a team who will support you. There would be a senior people, who would be kind of give you very direct instructions and guide you throughout the project. But there is a scope that you can grow in that whole in the ladder, and you can take up more responsibility. You can lead the project. You can run the entire program if it is a product-based company. So, so there is a immense opportunity for you to quickly grow in this particular field. So one is like if you come up with a very great solution which is directly impacting the business, and it is helping the business in achieving their objectives, then again, you will get immediate visibility and immediate growth, right? And if you have that leadership qualities, and if you have a good, if you are a good team player, and you can present things well, and you can interact with the customers in a better way, then again, there is a chance, you can grow quickly in this particular area. And even at the leadership, it's not other technology, I'm not kind of degrading them, but in other technologies which are more technical in nature, after a while, their growth gets saturated. Okay, they grow till certain extent, and after that, it's very difficult for them, to decide, what would be the next step, right? But here in this data scientist, as you have working closely with the business, you are working with the technology team, you have both the knowledge, then there is a high chance that you can get into a leadership positions on the management roles, right? So there is a new role which has I don't know whether you have heard about. So CAO, Chief Analytics Officer, and Chief Data Officer. Okay, so those are the new roles in the CXO level. Now you are seeing in the organizations where the people from data science, from data engineering, they are getting into that particular cadre. Okay, they are getting into that particular level, and even the CEOs and all the decision makers, uh, in some of the organizations, they are people from analytics background, because they can read the data well, they can analyze the data well, they can take better decisions, they know, where to use what kind of analytics. So in that way, they will be very comfortable in that decision making roles. So yeah, so a lot of things, guys, you guys have to kind of look into. Uh, this is something I wanted to share in today's class. I hope it would help you. Okay, so I'll stop it here now, as I have a meeting at 10:30. Uh, so tomorrow we will pick up new algorithm, okay, in the clustering. So we will talk about hierarchical clustering, and we'll see that how is it different with the k-means, and what is the pros and cons with hierarchical clustering, and then followed with the DB scheme. Okay. All right, guys, then thank you. Have a nice day. Take care.
Thank you, sir. Have a nice day.
Thank you. Bye-bye.